Concept 3, writing linear equations in slope-intercept form. So we are back to slope-intercept form. As I told you in the last video, this is the most important form. It's the easiest one to use. The reason we are looking at the point slope form is because depending on the information you are given, sometimes it's easiest to go into point slope form and then translate from there to slope-intercept form. Okay? So the steps for that are the same every time. All right? You have your point slope form. Okay? We've input our point, we've input our slope, if that's what we're given. Okay? And then to get it into slope-intercept form, we are going to go through a couple steps. The first thing we have to do is use the distributive property on the slope. So m times x and m times negative x1. Alright, that's what I've done here. Then we're going to move the coordinate value, right, the y coordinate value. So it's a negative y coordinate value, or negative y1. We're going to add y1 to both sides. All right, and then we come up with y equals mx minus mx1 plus y1. Okay, and you'll notice that this part of our equation is already there. Okay, we are in slope-intercept form for this part. The only thing is this looks a little funky. All right, but this actually, once you simplify it, is equal to the y-intercept. All right, having negative slope times the x value and adding the y value will always get you the y-intercept. Okay, if you want to try and remember this, negative slope times the x value plus the y value equals the y-intercept, you can, but it's pretty tricky. It's often easy to make mistakes, especially with that negative value. With the x and y coordinates, sometimes it's easy to make a mistake. So I don't recommend memorizing this formula. I would recommend putting it into slope-intercept form, point slope form, and then going through the steps to translate it into slope-intercept. Okay? Now, why are we doing that? Again, the reason is we can often get information that's difficult to put into slope-intercept form. Okay? If we have the slope and we have the intercept, that's easy. We just plug it in. Okay? Or if we have the intercept and we have another point on the line, that's pretty easy. We can find the slope and plug it straight into slope-intercept form. Okay? But if we have the slope, or we have 2 points on the line that aren't the y-intercept, it's often going to be easiest to start with point slope form and translate it into slope-intercept form. Okay, so let's do that a couple times. In this example, we're given the slope and a point on the line. So we start with our y minus y1 equals our slope times x minus x1, which is 4. Okay, distribute out. 2x, 2 times the negative 4 is negative 8. Okay, move the y coordinate over. Move the y coordinate over. Those will cancel, and we're left with y equals 2x minus negative 8 plus 1 is a negative 7, or y equals 2x minus 7. Okay? And if we went back up here, we could look at this and we could say, okay, a negative slope, so negative 2 times the x value of 4 plus the y value, negative 2, so that's going to be negative 8 plus 1 equals negative 7. Well, yeah, that does turn out to be the same thing. All right, but again, it's easier to make mistakes if you try and plug it in like this, and it's easy to forget the form. Okay? All right, so for this one, we're given 2 points, but we're not given the slope. Okay? So the first thing we have to do is find the slope, all right, which is slope formula y2 minus y1 over x2 minus x1. Choose your point. I'm going to call this point 1, and this is point 2. So y2, 8 minus y1, a negative 1 over x2, negative 2. Oops. See, made a mistake already. Just going to switch that. This will be my point 2. This will be my point 1. I've still got my values lined up correctly, so I can keep going. Minus a 1. Okay, so 8 minus negative 1 is going to be equal to 9. Negative 2 minus 1 is going to be negative 3, or this will be equal to negative 3. Okay, now I've got my slope. I can plug it in. Y minus, and I can choose either point. Doesn't really matter. I'll choose this point just because it's the numbers are smaller and it's easy to work with ones. So y minus a negative 1 equals m times x minus 1. Okay. Oh, and I can replace my m because I figured that out. It was negative 3. Negative 3. Distribute that out, and I'm going to do this at the same time. If I distribute those negatives, it's going to be y plus 1 equals negative 3 times x. And then negative 3 times a negative 1 is going to be plus 3. Move my y coordinate over, subtract 1 from both sides. Y equals negative 3x plus 3 minus 1 is 2. And there I've got it in my slope-intercept form, which is very easy to graph from. Okay, last one is pretty much the same as the one before it. Okay, I'm given the 2 intercepts, but these are actually just 2 points. All right, and for this one, I would actually not go into point slope form. All right, I'm given the y-intercept. Okay, so don't bother with point slope form. Go into your slope formula. Okay, I don't need to rewrite it. So this point, the y-intercept, is 0, negative 6, and this point is 0, 3. Oh, shoot, got those backwards. Sorry. Oh no, I didn't. That was right. What am I thinking? That's what I did. Okay. 3, 0. There we go. So now I can put those into my slope formula, make that 0.2, this one 0.1. So I have my y2 negative 6 minus 0 over 0 minus 3, which is going to be a negative 6 over negative 3, or, since it's two negatives, 2. Okay? And then I just have it, I've got my slope. The slope is 2x. My y-intercept is minus 6. And I'm done.